Today, we're going to take a look at a challenging multi-step word problem that involves dividing decimals using a model. Mia bought snacks from the pool's concession stand. The shaded part of the decimal grid below represents the part of $1 that she has remaining after purchasing her snacks. Mia decides to give all the money she has remaining to her 3 friends so they can buy some jawbreakers. These are pieces of candy, which cost 10 cents each. Mia gives each friend the same amount of money. Sam, one of Mia's friends, claims that if the 3 friends put their money together, they will be able to buy more jawbreakers than if they buy them separately. Is Sam's claim correct or incorrect? Describe a process that Sam could use to find the greatest number of jawbreakers that each of Mia's friends can buy. This is a huge problem. We are going to break it down into separate steps and think about questions that will help us organize our thinking. The first thing we need to think about is the situation. What is the situation? I'm going to go back and read my problem. And I'm going to think about where she is. Mia bought snacks from the concession stand, and she has part of $1 remaining. Okay, what does the decimal grid represent? Well, I think if I look back in the problem, it tells me right away. The decimal grid represents the part of $1 she has remaining. Okay, that's easy enough. How are the parts of $1 represented on the grid? Well, I know that this grid is one whole, and it's also divided into tenths. But these tenths are divided even smaller. These tenths are divided into smaller squares. These smaller squares are hundredths. So this is our one whole, this is our tenth, and these little squares are worth 1/100th each. What does the shaded part represent? So the decimal grid represents the part she has remaining. I think I need to go back up and reread this question again. The whole decimal grid represents $1. So the shaded part is what she has left. I'm going to count this. I have 9/10ths and 6/100ths. Okay, here's our answers. What is the situation? Mia brought snacks and has money remaining. What does the entire decimal grid represent? It represents $1. What is the value of the small squares on the grid? Well, they're each worth 1/100th of $1. What does the shaded part represent? It represents the part of $1 she has remaining after she bought the snack. How much money is represented by one small square? I'm asking you about a coin. What would we call that? Mia decides to give all the money she has remaining to her 3 friends so they can buy some jawbreakers. These are pieces of candy, which cost 10 cents each. Mia gives each friend the same amount of money. This is a lot of important information. We already determined that this grid is the remaining money. And we determined that is 96/100ths of $1, and sometimes we're going to write that so we can think about it as far as money. Jawbreakers cost 10 cents each. Mia gives each friend the same amount of money. Mia decides to give all the money she has remaining to her 3 friends so they can buy some jawbreakers, which cost 10 cents each. Mia gives each friend the same amount of money. What questions can we ask? Mia gives all the money she has remaining to her 3 friends. Well, how much does she have left? That's what remaining means. So I'm going to just go over this in orange just so my eyes are not tricked. Mia gives each friend the same amount of money. I'm going to highlight the word same. That's going to help me with this. What operation can we use to determine how much she gives each person? Finally, jawbreakers cost 10 cents each. Do those dentists know they're going to buy jawbreakers? Okay, let's answer those questions. How much does she have left? She has 96 cents left. We decided that we need to figure out an operation to decide how much she gives each person. I think we should divide it by 3 since there are 3 people. The dentist part we already answered. So we're going to go with, we're not going to tell their dentist. I'm going to do a visual model here on the next page to help us understand this better. Okay. Let's use the model to divide 96 into 3 groups. The first thing we're going to do is we're going to divide the tenths into 3 groups. I'm going to shade these. So we've got one group of 3, because I know 9 tenths divided by 3 is 3 tenths each. Okay, so I'm going to use my different colors here to help me. Okay, so I've got a group of 3 tenths, 3 tenths, 3 tenths, and now I'm going to go back and I'm going to divide my cute little hundredths that are left. Okay, that works. Okay, so I've got 3 tenths and 2 hundredths in each group. So that means that I have 32 hundredths and each friend will have 32 cents. Whew. Last part, we're doing really great. Is Sam correct or incorrect? We're going to put his claim into math language. Sam says they can put their money together. They can combine their 32 cents. So they can add or they can multiply. So how much money will they have all together? They'll have 96 cents because 32 hundredths times 3 is 96 hundredths. Interesting. We knew this already. Where did we get this information? They told it to us in the very beginning. So we could have figured out that if they were sharing their money, when they combined it, it would be back to the original amount. Now we can determine the best way for them to spend their money and see if Sam was right. If they bought jawbreakers by themselves with their own money, each person has 32 cents. They can each buy 3 jawbreakers because they take their 32 cents and they divide it into 10 cents for each jawbreaker and they get 3 jawbreakers. If they do that, they'll have 2 cents left over. Now, if they combine their money, they'll have 96 cents combined. They can buy 9 jawbreakers. 96 divided by 10 cents. 96 cents divided by 10 cents equals 9. Then in this case, they will have 6 cents left over. I know this is accurate because if they each have 2 cents left over, 2 hundredths times 3 people equals 6 cents, which is the same as what they have left over here. So, individually, 3 jawbreakers times 3 people, 9 jawbreakers. Combined, 96 cents will buy 9. Sam is incorrect. They would be able to buy the same amount of jawbreakers either way. Can you think of an easier way to solve this problem? Thanks for listening.